Good morning, everyone. So we will continue our lecture for today. So as I already informed you last week, so this week shall be the last week for lecture lah. Means today and tomorrow, I will finish the last chapter for our design project. So and then week 10 pun you all dah start lab. So I also cannot do any class. So the lecture will finish this week. Today and tomorrow, I will finish energy balance, and then you can already proceed for your project report 2 lah. Okay, so for those under my supervision, your consultation is as usual this week. And as I told you, for those yang consultation under my group, for your consultation, please make sure you have all the information needed, which I told you for mass balance. You need the information on the compositions, conversions, so on and so forth. For those yang tak ingat, you can refer back to the video last week. For energy balance pun, I need certain information which I will explain later as we go on this chapter. Okay, so similarly to mass balance, energy balance pun, you need to understand lah the method, so on and so forth. But similar to mass balance, I won't teach you all the methods sebab kalau reactive sebenarnya ada lebih pada satu method. So I will just teach you the method that I think is the easiest one for you to understand and catch up and start doing the project. Okay, so as I tell you again, saya tak ada semua method, but let's say you prefer to use the other method that you are quite familiar with, you are feel free to do so, right? So similar to mass balance, energy balance pun ada, there will be 2 students who are doing energy balance, because one will be doing manual calculation, another one will be doing the simulation using software. So software pun, as I said, I give you option, Excel or Aspen HYSYS or any other software that you're familiar with. Just that in my class, I will use Excel so that to make sure that everybody will not have any problem accessing to it. Tapi sama je, whether you use Excel ke, you use HYSYS ke, you do manual calculation pun, at the end of the day, if you use the same information, the answer will be the same. The calculation will be the same. So, sama juga for those yang nak buat energy balance nanti, supposedly 2 students who will be doing on the energy balance, you are supposed to share the information. You're supposed to use the same information untuk calculate. So kalau you all work together, you get the same answer from simulation and manual calculation, most likely should be correct lah. But if let's say you dapat jawapan yang berlainan, you get answers different from each other, there will be a slight difference for sure. Bila kamu kira final answer tu, you will have a slight difference in the answer for sure, manual dengan simulation. Tapi but if your answer differs very much, then most likely either one of you guys make a mistake in the calculation, or sometimes you don't use the same information. Okay, so nanti I will explain apakah itu information yang sepatutnya digunakan sama. Right, so same concept. For those energy balance, okay, you don't necessarily need to do energy balance untuk semua equipment. Okay, so same pemahaman yang paling mudah yang kita buat energy balance ni actually is to find Q. Okay, Q tu apa? Q tu adalah heat, either supplied or released from the equipment. Tapi Q ni tak semestinya you have to calculate for all equipment. Okay, so that's the first understanding. Q is not necessarily you have to calculate for all equipment. Okay, so then you might wonder, that equipment mana yang memerlukan kita mengira Q? Okay, to do so, to understand so, for each equipment, for those who are doing energy balance, you have to have first cari information, 3 important information, which by right in report 1 you have done. But I check from the report yang saya dah tanda pun report untuk part 1, ada few groups yang still tak complete lagi dia punya stream condition, which is temperature and pressure. Okay, some of the group I tengok tak ada langsung pun. So in report tu you dah tak boleh buat ni. Kalau tak ada condition, temperature dengan pressure, you cannot do the energy balance. Okay, so for those group yang belum ada lagi, sebab ada certain group is not under my supervision, I didn't realise it. Nanti saya check report 1, saya perasan ada group yang tak ada lagi temperature, pressure punya condition. So for those group who haven't have it, you have to have temperature, pressure, condition for all the streams, semua stream. Katakan you ada 10 stream number or 20 stream number, every stream tu kena tahu dia punya temperature and pressure. And now additionally one more information, the phase, fasa phase of all the compound in the stream. Okay, so contohnya dalam slide ni you can see, let's say for stream 1, okay, I know the compound, I know the temperature, pressure, and I know the phase as well. Either it's gas phase ke liquid phase. So the phase you must know for all the compounds in that stream. Okay, kalau tak ada information ni memang tak boleh buat energy balance. Alright, so I realize in report 1 ada few groups lah yang tak ada lagi information complete ni. So without this information, you cannot start on your energy balance. Okay, so for those group under me, by this consultation this week, make sure all your stream punya information tu dah cukup. Especially for energy balance, you need to know temperature, pressure, and the phase for each compound. Okay, so then after you know these 3 conditions, then only you can determine which equipment yang kena atau tak payah buat energy balance. Okay, for equipment yang you can see, let's say katakan equipment tu you have to check the inlet stream and the outlet stream. Okay, so for each equipment check inlet stream, outlet stream. Kalau if there are changes of either temperature or pressure or phase, then you have to do energy balance for the equipment. Means perubahan suhu atau tekanan atau fasa antara inlet dan outlet stream. If there's changes, you have to do the energy balance. This included reactor. Kalau reactor tu pun tak ada perubahan suhu pun, tapi dia ada tindak balas, you have already to do the energy balance. So for example, okay, I take one example. Okay, case yang pertama ni mixer. Okay, kalau kamu tengok mixer ni, inlet stream dia 1 and 7, outlet stream dia 2. Okay, so inlet stream 1, you can see all is gas, 100 Celsius, 1 atm. Inlet stream 7 to the mixer also all gas, 100 Celsius, 1 atm. Sama kan? And the outlet stream to the mixer all also gas, 100 Celsius, 1 atm. You can see in the mixer there are no changes of temperature, no changes of pressure, no changes of phase. Then you don't have to do the energy balance for mixer. Okay, done. Okay, then you see reactor. Reactor, kalau reactor mesti tindak balas berlaku. If reaction occurs, regardless ada perubahan suhu ke tak, you already have to calculate the Q for the reactor. Okay, next, flash separator. You can see the flash separator, the inlet stream is all gas, 500 Celsius, 5 atm. Outlet stream dia, outlet stream 5, all gas, but there's one liquid. You can see the ammonia that comes out is not liquid. Okay, so there's a change of phase. Suhu pun 200 Celsius, change of temperature, pressure maintain. So perubahan salah satu daripada temperature, pressure or phase, you already have to calculate the Q. So for this case, ada perubahan temperature, you got the change of phase, you have to do the energy balance for flash separator. So on to the separator, the second separator at the top, there are changes of temperature, there are changes of phase, there are no changes of pressure, but ada perubahan suhu, ada perubahan fasa, you already have to do the energy balance. So in this process, you have 4 equipment, but there are only 3 that you need to do energy balance. Okay, but I understand. I realize maybe nanti ada certain group dia nak elakkan buat Q, disamakan temperature, samakan pressure, samakan phase. You cannot do so because kalau let's say dia adalah separation process, kalau separation tu melibatkan disebabkan perubahan suhu, definitely ada perubahan suhu. Contohnya macam flash separator, you definitely have to do at certain boiling point. So kamu tak boleh sebarangan tak nak buat untuk equipment tu, kamu samakan semua temperature, samakan pressure, samakan phase. Okay, you must understand you cannot simply choose the condition up to you. Kalau dia melanggar fundamental concept, boiling temperature semua, kalau kamu tak buat, you will get 0 for it. So you tak boleh escape buat energy balance based on assumption kita samakan temperature, tak payah buat energy balance. Cannot. So for example, flash separator definitely will have Q. So if you don't do it, then cannot. Okay, so please understand. Macam mixer tak apa, mixer memang kita tahu mixer will not have any heat supply or heat release. So certain equipment tu kita dah boleh agak akan ada Q ke tak ada Q. So macam reactor, separator, distillation column, heat exchanger definitely will have the value of Q. Compressor depends. Kalau the compressor, the change of pressure is more than certain pressure, you will need to do the calculation for the Q. Okay, so later we will address mana case yang kena kira Q, mana case yang tak payah kira Q based on what assumption. Okay, so that's the first understanding first. So for those group under me, by having enough information during the consultation, I can already tell you, I can already tell you which equipment that you will need to calculate Q, which equipment you don't need to calculate Q. Okay, so it's important to have the strict information so that we can know which one to calculate Q, which one you don't need to calculate Q. Okay, so next. Just to recap back, okay, dalam PFD kamu nanti in project report 1, you did not add the stream information table yet sebab dalam project report 1, we don't have the information on the mass balance and energy balance. So kita tak masuk lagi stream information table. In report 2, you have already include the stream information table. And for those doing energy balance, you have to include in the stream information table the row yang paling last, the enthalpy, the Q that you calculated from your energy balance. So stream information table tu memerlukan information daripada mass balance, which is the molar flow rate and mass flow rate. And also need information from the energy balance, which is actually the value of Q. So equipment mana yang kamu kira Q tu, kamu kena letak dalam enthalpy information table, industry information table, what is the value of the Q that you calculated. So bear in mind, stream information table is needed in project report 2 di bawah PFD kamu. So for those project report 1, PFD yang tak perfect lagi, make sure you do it, you correct it in project report 2. So I will say about out of 9 group, saya rasa dalam 3-4 group memang tak settle lagi dia punya PFD. So project report tu dah tak boleh lah, kamu kena settlekan. Okay, right. So next one. For energy balance calculation, I think you remember, right? We use a lot of appendix table from the Felder and Rossi book, Elements of Chemical Process Principle, yang buku rujukan tu. You will need a lot of information from the appendix table. Okay, so I have provided the appendix table in the VLE, tapi do bear in mind appendix table ni pun limited. Okay, if let's say you're using common compounds, information tu ada dalam appendix table Felder and Rossi. But not necessary for all. If your compound is not so common, you might need to find from other reference book or you need to Google it on the internet. Okay, so kalau information tu tak ada, please Google it from the internet. Okay, next. Nak tengok appendix table pun kena faham information dia. Although you have learned before in CPP, but I will just recap back. Okay, so ada certain table yang kamu akan guna information dia. Biasanya table B1, B4, B8 and B10. Okay, so I will explain certain table yang saya rasa relevant lah. Okay, so in table B1, if you see this table, there are certain information yang kamu kena tengok. First of all, compound lah. Okay, depending on your compound, you will see the information depending on your compound. Second, you can see formula, dia punya chemical formula. Third is the molecular weight. So if you need to use molecular weight, please make sure you use this appendix table or you can Google also, no problem. Fourth column is the specific gravity. Most likely you don't use the specific gravity, not so bad. Column number 5, TM. So TM stands for melting temperature. Nanti saya akan explain kemudian kenapa kena tahu. So Nak tengok melting temperature, go to column number 5, TM, melting temperature. This is in Celsius. So bear in mind, melting temperature dalam appendix table ni dalam bentuk Celsius. Okay. So melting temperature tu maksudnya apa? Temperature of which the compound in solid become liquid. Ataupun dia boleh terbalik juga. Kalau solid ke liquid, dia melting temperature kan. Kalau dia daripada liquid kepada solid, this is solidification. Solidification terbalik lah. Melting solid liquid, solidification liquid solid. Tapi ia masih juga berlaku pada suhu yang sama, pada melting temperature juga. So it's either one way. Okay. And then for that melting temperature, there are also heat of melting. Kamu tahu tak, bila ada berlakunya melting process, akan ada haba yang di-release. Okay, this is called as melting, enthalpy of melting, or we also can call it heat of melting. So this heat of melting only occurs at the melting temperature. Means bila benda compound tu melt jadi pada solid menjadi liquid, haba yang dibebaskan adalah we call as heat of melting. Okay. Next one, column is TB. TB is for boiling temperature. So boiling maksudnya daripada liquid kepada gas or liquid kepada vapor. So this is also in Celsius. And then terbalik juga pun samalah, kalau liquid kepada gas or liquid kepada vapor, we call it as vaporization kan. Okay, so kalau terbalik vapor kepada liquid, we call it condensation. Okay, so sama ada vaporization or condensation, dia masih berlaku pada suhu boiling temperature. Condensation temperature, boiling temperature tu sebenarnya adalah sama maksudnya. Kalau liquid tu kamu panaskan, katakan contohnya acetic acid katakan acetic acid ni dalam bentuk liquid, you heat up, katakan acetaldehyde, boiling temperature dia 20.2, meaning kalau acetaldehyde tu you heat up dalam bentuk liquid acetaldehyde, you heat up until 20.2, you will get vapor acetaldehyde. Okay. Same concept, katakan vapor acetaldehyde ni you cool down until 20.2, dia akan jadi liquid acetaldehyde. So it occurs at the same boiling temperature. Okay, so this heat or enthalpy at boiling temperature, we call it as heat of vaporization, delta HV, heat of vaporization. Haba yang diperlukan untuk bahan itu from liquid jadi vapor, that one is called heat of vaporization. Bila kamu panaskan satu benda, means liquid jadi vapor. Bila kamu panaskan, means kamu bekalkan haba, right? You supply heat. That heat that you supply is called heat of vaporization. Opposite pula, katakan bila kamu sejukkan bahan yang vapor tu, kamu sejukkan. Bila kamu sejukkan, heat will be released. Heat and release tu adalah heat of condensation kan? So itu dah heat condensation. So heat yang when you heat up, bila kamu panaskan, kamu bekalkan haba. Bila kamu sejukkan, kamu bebaskan haba. So when you get an equipment, kamu kira Q, the Q can be negative or positive. Apa maksud dia? Katakan kalau equipment tu melibatkan pemanasan, involve heating, you are supplying heat, the Q will be a positive Q. But if your equipment is cooling down, you are cooling down the equipment, means the equipment will be releasing heat, your Q will be a negative Q. So bila kamu kira Q, kamu dah boleh agak. Kamu kira Q tu betul ke tak betul. Kalau Q equipment tu memang melibatkan addition of heat, the Q is positive. But if your equipment is releasing heat ataupun equipment tu undergoes cooling down, the Q will be a negative Q. Okay, so that's another sign whether kamu kira betul ke tak betul. Right. Then next, you will see TC, PC ni kamu tak gunalah. Critical temperature, critical pressure, you don't. Let's say untuk case acetic acid, you can see there's two heat of formation, right? Negative 486.18, negative 438.15. Kenapa ada dua jenis heat formation yang berlainan? Depends on whether you want to see the heat of formation of the compound in liquid phase or the heat of formation of the compound in gas phase. So katakan kamu nak katakan bahan itu adalah gas and you want to use the heat of formation, you must take the one that falls under gas. But if the compound is liquid, then you must choose the heat of formation for the liquid form. Okay, so I will explain you later apakah relevannya information ni. Okay, so that's to inform, to make you remember back how to use the table. Next one. Table B2, heat capacity. Remember CPDT, heat capacity at constant pressure. This one also will be used to calculate for the enthalpy for the heat. Tapi ada certain information yang kamu kena faham dalam table ni. Alright, so first of all, table ni pun sama. Setiap compound will have different value of your CP depending on the phase. So you must be very careful. Contohnya acetone, dia ada dua nilai. Kamu tengok dua row nilai CP yang berlainan. Why? Each row is for different phase. So katakan you want to calculate for CP for acetone liquid, you use the first row. If you want to calculate CP for acetone for gas phase, you use the second row. So part ni pun kena faham nilai CP tu also specific to the compound. And nilai CP dalam table ni pun quite limited for certain compound only. So if you don't have, please find from other reference book or find from the internet. Okay, next. Kalau kamu ingat CPDT tu kan ada nilai A, B, C, D. Nanti saya akan explain kemudian jugalah. Nilai A, B, C, D ni juga you have to be very careful. In the diagram, in the table, nilai A, B, C, D tu dia tulis sebagai times 10 power 3, times 10 power 5, 10 power 8, 10 minus 12. But in your calculation, you have to use it as A times 10 power minus 3, B times 10 power minus 5, C times 10 power minus 8, D is 10 power minus 12. So this part pun jangan lupa, walaupun dalam table tu tulis 10 kuasa 3, 10 power 5, 10 power 8, 10 power 12. But in calculation, you have to use 10 power minus 3, minus 5, minus 8, minus 12. Okay. Tapi nanti dalam saya akan tunjuk contoh lagi. Another table that you will also use table B8. Okay, so table B8 ni sebenarnya alternatif kepada table B2. Kalau B2, kamu kena kira manually. Table B8 is more straightforward sebab kamu boleh terus ambil bacaan using the table. Tapi table B8 ni pula, dia ada juga dia punya limitation. It's only for certain compound and basically is for all types of, it's only for gases, selected gases, which is air, O2, N2, H2, CO, CO2, H2O. Even H2O ni pun dalam bentuk vapor, means above 100 Celsius. Okay, so kalau menggunakan ni lebih straightforward sebab setiap temperature tu dia dah bagi kita straight away nilai enthalpy. Kalau table B2 tadi tu kita kena kira manually which take a lot of time. Tapi it depends. Tak banyak compound yang ada dalam table B8. If so happen your compound is in table B8, you can also use table B8, which I also will explain again in my lecture after this. Okay? Okay, right, done. So that is understanding on the enthalpy on the appendix table. So now is starting to do energy balance. Okay, so for those who do energy balance, first step sama je dengan mass balance. You have to do the block diagram, a complete block diagram. Dan beza dia sikit, kalau macam mass balance, dia tak payah tahu pasal temperature dengan pressure. For energy balance punya, kamu kena tambah sikit. You have to know each stream yang masuk dan keluar equipment tu, what is the temperature, pressure and the phase of each of the compound. So for example dalam case ni evaporator, so inlet dia is I write down hexane, benzene, both vapor phase, and then I write down 65 Celsius 1 atm. Yang keluar top stream, bottom stream, top stream hexane, benzene vapor 25 Celsius 5 atm. Bottom stream, hexane, benzene, liquid phase, 25 Celsius, 5 atm. So kamu kena faham kalau ada perubahan suhu, tekanan or phase between inlet and outlet, you have to calculate the Q. Okay, so that first step, complete inlet outlet enthalpy, complete block diagram first. Second stage, you have to then do the inlet outlet enthalpy table. Mass balance, kamu kena buat mass balance table. For energy balance, you have to do the inlet outlet enthalpy table. So apa yang diperlukan dalam table tu? First, the table must have reference condition. Kalau table tu tak ada reference condition, means your entire energy balance is wrong. So please make sure before kamu buat table tu, kamu kena letak reference condition. I will teach you later how to choose the reference condition. Nak pilih reference condition pun, there are certain rules and regulation that you have to follow. Tak boleh sebarangan ambil. Reference condition ni pun kena complete untuk setiap compound. Contohnya, untuk hexane, you have to have its own reference condition. Untuk benzene, dia punya reference condition. And condition ni pun must include 3 important information dulu lah. Temperature, pressure and the phase of the compound. So katakan macam hexane, the reference condition, vapor 65 Celsius, 1 atm. Benzene, vapor 65 Celsius, 1 atm. Reference condition for the compound, for the separate compound can be different. Tak semestinya kena sama. Maksudnya, hexane, benzene ni katakan kamu nak pilih reference condition yang berlainan, boleh je. Boleh. Okay? But most important is, setiap satu compound tu, you mesti put down the reference condition. Okay, so then we go to the table. Okay, to go to the table, kita pergi row dulu. Okay, so each of the compound, kalau dia wujud dalam fasa yang berlainan, if the compound exists in different phase in the diagram or in your process, dia ada row dia sendiri. Okay, so kamu kena tengok. Katakan dalam case ni, hexane tu ada, hexane and benzene exist in liquid and vapor, right? So each of the compound tu akan ada row yang berlainan. Hexane vapor, hexane liquid, benzene vapor, benzene liquid. So kalau compound tu wujud dalam dua fasa yang berlainan, make sure that you have different row for it. Okay, so kamu tak boleh buat benzene tu satu row saja. Jadi kalau wujud dalam fasa berlainan, dia kena ada row yang berlainan. Okay, next, column. Column tu terbagi kepada dua, inlet column, outlet column. Okay, so kena tengok ada inlet column, outlet column. Okay, inlet column pula terbagi kepada dua. Kenapa terbagi kepada dua? You have to calculate, bukan calculate, kamu kena include dua information. First, NIN. NIN ni adalah molar flow rate untuk setiap compound yang masuk. Maksudnya, contohnya dalam kes ni, yang masuk dalam evaporator ni, hexane vapor dengan benzene vapor kan? Okay, so kamu tengok. Hexane vapor tu akan ada molar flow rate dia. Benzene vapor akan ada molar flow rate dia. Kamu tengok hexane liquid, benzene liquid dalam ini saya letak dash. Kenapa? Sebab dalam inlet ni tak ada hexane liquid dengan benzene liquid, right? Kalau tak ada, kamu dash kan untuk molar flow rate yang tak wujud. Okay, so molar flow rate ni nak dapat daripada mana? Molar flow rate ni kena dapat daripada your friends that are doing the mass balance calculation. So the molar flow rate part, for those buat energy balance, kamu tak payah calculate mass balance part tu. Molar flow rate tu please get from your friends who are doing the mass balance calculation. So for the mass balance calculation, kamu kena provide semua information molar flow rate yang kamu dah calculate. So means kamu tak boleh buat last minute nak hantar Isnin, Ahad, Isnin tengah malam, Isnin petang baru nak siap. Tak boleh sebab then those energy balance dia tak boleh buat final calculation dia. So by right, mass balance dah kena start dulu. That's why you have mass balance, you have to do a little bit fast sebab kalau tak ada information mass balance, energy balance dia tak boleh letak dia punya information ni dalam table dia. Dia tak boleh calculate Q. Okay, so energy balance, make sure you done this fast. Okay, second column is the enthalpy. H in tu adalah enthalpy in. So enthalpy in ni pula nanti kamu akan faham Kalau ada nilai molar flow rate, kamu kena kira entalpi dia. Okay, so but in certain case, entalpi tu boleh menjadi kosong. Why? Okay, case ni adalah kerana katakan kamu punya reference condition tu sama dengan inlet condition. Ni contohnya dengan case ni, saya pilih inlet condition as the reference condition. Kamu perasan tak saya pilih reference condition dia hexane vapor 65 1 atm, benzene vapor 65 1 atm. Sama kan? Kalau reference condition sama dengan inlet condition, dia tak ada perubahan entalpi kan? Sebab tu saya letak sebagai kosong. Sebab that condition to calculate that inlet punya entalpi sama dengan reference condition. Okay, itu adalah jika if you choose inlet as the reference condition. Tapi katakan you pilih reference condition yang lain, okay, means you have to calculate the entalpi. Entalpi hanya boleh dikira or you only need to calculate if there are molar flow rate. Ada molar flow rate, kira entalpi. Ada molar flow rate, kira entalpi. So macam contoh case hexane liquid ni, kalau kain, saya tak kira entalpi dia sebab tak ada molar flow rate, tak payah kira entalpi. Okay. Then you will calculate the total enthalpy in. Sorry, ni yang salah. Total enthalpy in, bukan total enthalpy out. This one should be total enthalpy in. Sekejap ni. Total enthalpy in. Okay. So then you will calculate total enthalpy in. How to calculate total enthalpy in? You do molar flow rate N1 darab dengan enthalpy 1. In this case, so happen enthalpy 1 ni, enthalpy ni 0 kan? So N1 darab 0, 0. Plus N2 darab dengan 0, again 0, right? So enthalpy in is actually 0 in this example. Okay, just because sebab saya pilih reference condition sama dengan inlet condition. Okay, so done. Outlet part ni yang kamu kena faham juga. Okay, outlet part ni sama. You have to include molar flow rate daripada the mass balance punya students yang buat calculation. Sebagai contohnya, katakan N3 ni katakan 1000 kilomol per hour. Kamu letak N3 1000. Katakan N5 ni adalah hexane liquid punya molar flow rate. Let's say 2000 kamu letak. So information ni kamu dapat daripada those yang buat energy balance. Okay. Kalau that box have the value of the molar flow rate, kamu kena kira entalpi. Okay, saya harap kamu faham kenapa ni N3 sebab hexane vapor di atas N3. Kenapa ni N5? Sebab hexane liquid is N5. Benzene vapor atas N4, benzene liquid bawah N6. Okay, so then calculate entalpi pula. So kalau ada N3, ada molar flow rate ketiga, ada entalpi ketiga. So how to calculate this entalpi? Dia mesti always entalpi pengiraan bermula daripada reference condition to that specified condition. Maksudnya, katakan nak kira H3 ni, dia adalah daripada reference condition hexane vapor 65 Celsius 1 atm. Reference condition kan, permulaan dia mesti daripada reference condition. Dia punya ending H3 ke atas, kamu tengok ke atas, condition dia apa? Hexane vapor 25 Celsius 5 atm. So kamu tengok sini saya letak hexane vapor 25 Celsius 5 atm. Means H3 yang kamu kira adalah perubahan entalpi atau perubahan haba from reference condition vapor 65 1 atm kepada top condition yang atas tu vapor 25 5 atm. Next one, H4. Katakan saya bagi H4 H4 kamu tengok adalah untuk benzene vapor. So it's from reference condition benzene vapor 65 1 atm to top condition benzene vapor 25 Celsius 5 atm. That is to address to calculate H4. H5. H5 kamu tengok adalah untuk apa? Hexane liquid yang keluar di bawah kan? So dia start again daripada reference condition hexane vapor 65 1 atm, but now my H5 is to hexane liquid 25 5 atm. And lastly, H6 is for benzene liquid kat bawah. So again from reference condition, benzene vapor 65 1 atm to benzene liquid 25 5 atm. So kalau kamu tengok kat permulaan kamu punya pengiraan tu, dia mesti bermula daripada reference condition kamu. So that's why you see all the same reference condition, tapi dia punya the last to where you are calculating the enthalpy, ia bergantung kepada enthalpy mana yang kamu nak kira. Katakan H3, kamu tengok H3 vapor yang ke atas. So kamu tengok vapor ke atas apa dia punya condition. So on and so forth. So energy balance ni tak susah, tapi a bit tedious sebab banyak pengiraan yang sebenarnya kamu kena buat. Okay, so you have to calculate first H3, H4, H5, H6. Setiap satu enthalpy ni ada pengiraan dia yang separately. Okay, and this calculation kamu tak boleh buat straightforward. We will need to use hypothetical path. Nanti saya akan ajar kemudian sekejap lagi how to do hypothetical path. Means kamu tak boleh terus kira straight nak dapat H3 ni. Tak semestinya. Most of the time you have to do hypothetical path untuk kira enthalpy ini. Okay. Then let's say you dah calculate H3, H4, H5, H6. You will include in the table, alright? And then you will calculate the total enthalpy out. Total enthalpy out sama dengan N3H3 plus N5H5 plus N4H4 plus N6H6. Means kamu darabkan N3 dengan H3, kamu darabkan tambah dengan N5H5, you multiply them, you add, and then you will get the total enthalpy out. Dah dapat total enthalpy in, total enthalpy out, baru kita kira Q. Apa tu Q? Q adalah heat kan? Heat supply or heat release from the equipment. So Q tu adalah total out tolak total in. So later kita bertengok the formula how to calculate Q. So that's the gist of doing energy balance, block diagram, reference condition, inlet outlet enthalpy table, and kira Q. Dalam contoh ni saya tak tunjuk Q lagi, tapi kamu kena kira Q, the enthalpy. Okay, done. So next one is on hypothetical process path. So remember tu, you untuk pengiraan enthalpy ni kita tak boleh straightforward kira. Kita kena kira menggunakan what we call as hypothetical process path. So apa tu hypothetical process path? Okay. Hypothetical process path ni ada certain rules yang kamu kena faham. First of all, dia path kan, dia perjalanan kan? Okay. So perjalanan ni mesti ada permulaan, you got beginning, you got ending, right? So the beginning of the process path mesti reference condition kamu yang kamu pilih. Okay, so sebab tu kata reference condition tu kamu kena clear. Reference condition dia mesti ada compound, nama compound tu, phase, pressure, temperature. Which usually we will use the reference condition. So that's the beginning. Okay, so the ending to the path is the condition of which you want to calculate the enthalpy. Ingat tak tadi contoh saya bagi, katakan kamu nak kira enthalpy untuk benzene at top product. So kamu kena tengoklah top product benzene tu apa dia punya phase, temperature and dia punya pressure. Okay, so you have beginning, you have ending. Okay, so contoh yang saya nak bagi senang hypothetical process path ni adalah katakanlah kamu nak pergi from you want to go from my set, you want to go to Muar. Okay, my set to Muar. Okay, so you know right, to go from my set to Muar, there are several ways. First way, you can go directly. Kamu boleh guna AMJ directly from my set to Muar. You use one way AMJ, kamu boleh sampai. That's one way. Okay, but most of the time, sometimes, let's say, you cannot use AMJ. Katakan AMJ tu traffic light banyak, kamu tak nak guna AMJ, you want to use other alternative. Tapi kamu nak sampai Muar juga. So, first alternative, you can actually from my set, you go to Tol Simpang 4, you keluar Tol Jasin, masuk balik AMJ, you sampai Muar. One, that's a hypothetical path, right? Maksudnya, from my set, you go through highway Simpang 4, you will keluar at Tol Jasin, one path. Tol Jasin pergi AMJ, path kedua, path ketiga AMJ straight to Muar, three path. You will still reach Muar, but you will use three different separate path. Rather than tadi kalau guna AMJ, satu straight path. Another alternative path is you can actually go from my set, you go guna jalan lama, you will go to Air Keroton, one path. Air Keroton, you go to Jacinto, second path. Jacinto, you go to AMJ, third path. AMJ pergi Muar, fourth path. So you see, either way that path that you choose, eventually you reach Muar, but you use some one direct path, some will need 3 different paths, some will need 4 different paths. Okay, so then you might ask, apa perbezaan path dia? Okay, katakan perbezaan path dia, katakan AMJ free path, satu jalan tak payah bayar duit. Path menggunakan Jasin, simpang 4 kepada Jasin, you have one boundaries, kamu dah kena bayar tol. Tapi tol tu adalah lebih mahal. Kalau path ketiga, path jalan lebih banyak, tapi guna Air Keroh, dia punya tol lebih murah. So meaning is each path yang kamu pilih tu ada limitation dia. Apakah limitation dia? Okay, now we are doing enthalpy calculation, alright. Bila kita nak tengok beginning and ending dia, kita kena tengok apa yang berubah daripada beginning to the end. Meaning, let's say dalam kes yang saya bagi ni, the beginning is phenol solid 25 Celsius 1 atm. The ending dia adalah kita nak jadikan dia phenol juga, tapi sekarang dia adalah vapor phase 300 Celsius 3 atm. Okay. Bila kamu tengok dalam path ni, dia ada 3 benda yang berubah kan. The phase berubah, fasa dia berubah, temperature pun berubah, pressure pun berubah. So bila ada 3 perubahan, kita dah tak boleh kira direct enthalpy dia. Means katakan enthalpy tu delta H, kita dah tak boleh kira direct perubahan enthalpy tu sebab ada 3 benda yang berubah dalam sistem tu. Meaning pressure, temperature and phase. So what do we do is, kita kena create smaller path. And each of the path hanya boleh berubah satu benda saja. Means one path is to address change of temperature. Another path to address the change of pressure. Another path is to address the change of phase. Maksudnya bila kita ada perjalanan tu, setiap path tu hanya satu benda yang boleh berubah dan kita kena kira separately enthalpy ini untuk mendapatkan enthalpy yang sebenar. So contohnya dalam kes phenol ni, okay, kes phenol ni pun a bit complex apabila it involve the change of phase, perubahan fasa. Kamu perasan tak? Phenol yang masuk adalah solid, phenol yang keluar adalah vapor. So kamu tahu kan, untuk nak menukar daripada solid kepada vapor means you have to first melt the solid to liquid and then you vaporize menjadi vapor. So setiap perubahan fasa ni pun juga akan ada satu path sahaja. Means kamu tak boleh directly tukar kepada solid kepada vapor. You have to first change solid kepada liquid and then liquid kepada vapor. And then when you want to change solid to liquid, you tak boleh sebarangan tukar kan. Kamu kena, contohnya pada solid kepada liquid, it will only change phase, dia akan hanya bertukar fasa pada melting temperature. Meaning saya kena bawa solid phenol saya ni kepada melting temperature saya, dia jadi liquid kan. Okay, liquid ni saya kena bawa lagi kepada vapor temperature saya, which is my boiling temperature, baru dia jadi vapor. So bila kamu ada perubahan fasa, kamu kena careful on the selection of the temperature of which it occurs. Okay, maksudnya macam ni. Contoh dalam kes ini, kalau ada perubahan fasa, okay, you have to first bring down to the temperature or bring up to the temperature of which it change the phase first. Contohnya, dalam kes phenol ni, saya nak tukar kepada vapor kan, okay, saya kena tukar dulu kepada liquid. So, for it to become liquid, saya kena check apakah melting temperature phenol. Melting temperature phenol from table B1 adalah 42.5. Meaning, phenol solid saya yang 25 Celsius tu, first path, I will heat up first untuk menjadi 42.5. So, kamu tengok path yang pertama adalah perubahan suhu. Saya bawa dahulu saya punya compound from 25 to 42.5. Path pertama. When dia dah sampai 42.5, dia bertukar fasa from solid to liquid. Path yang kedua. Kamu tengok path pertama perubahan suhu bawa kepada melting point. Path kedua dah sampai melting point, tukar fasa. So there's a change of phase from solid to liquid. Okay, so now I got liquid at 42.5, 1 atm. Tapi tak boleh kan? Fasa akhir yang saya nak adalah apa? Vapor. So apa yang saya buat lagi? I further heat up to boiling temperature. Boiling temperature kena tengok dalam table B1, phenol boiling temperature 181.4. So now I further increase my temperature from 42.5 to 181.4. That one path is my third path. So saya kena dapat third path yang ketiga. So sekarang saya dah capai liquid 181.4. So pada liquid 181.4 dia akan bertukar fasa as is a boiling point. It will become vapor. So the fourth path is the change of the phase, tapi tak ada perubahan suhu, tak ada perubahan tekanan. Kamu perasan tak? Setiap satu path kecil ni hanya satu yang berubah. Suhu atau fasa ataupun pressure. Okay, so means bawa kepada temperature tu dulu, panaskan, dah sampai temperature tu, tambah satu path untuk perubahan fasa. Okay, now I already get vapor 181.4, 1 atm. So kamu tengok, kamu compare dengan yang terakhir, vapor dengan vapor saya dah dapat. Suhu tak lagi kan, the suhu is still not yet, the pressure is also not yet. So the next path, I will heat up far more to 300 Celsius sebab suhu akhir yang dia nak adalah 300 Celsius. Pressure masih sama. So phase is the same, pressure the same, temperature only I increase to 300 as that's the temperature that they want. And eventually the final path adalah naikkan pressure kepada 3 atm yang the path, the ending path wants. So kalau kita tengok dalam path ni untuk kira delta H, delta H tu adalah combination of 6 different path and each path ni kita kena kira dia punya enthalpy. Means untuk mendapatkan delta H sebenar, kita kena kira delta H1 tambah delta H2 tambah delta H3 tambah delta H4 tambah delta H5 tambah delta H6. So satu enthalpy kamu mungkin melibatkan pengiraan 6 separate enthalpy or more to get that one enthalpy reading. So contohnya dalam kes tadi yang saya tunjuk kamu. Contoh kes ni kan, H3 ni. So mungkin untuk mengira H3 ni, you might need 3 separate path. Means katakan H3 ni melibatkan pengiraan HA1, HA3 tambah HB3 tambah HC3. Baru kamu dapat H3, something like that. Okay, so each enthalpy calculation might need separate hypothetical process path. So kamu kena faham hypothetical process path ni bagaimana ia berlaku. Okay, so done. Kan tadi saya dah address kan, setiap pengiraan enthalpy, you have to calculate separate enthalpy for the change of temperature, change of phase, change of pressure, right? Okay, so we have to address now. Macam mana kita nak kira enthalpy tu? Okay, so untuk perubahan suhu, to calculate the change of enthalpy due to change of temperature, kita biasanya guna table B2 atau tadi table B8. So table B8 tadi tu more straightforward kan. Table B2 ni involve little bit of integration. Integration using table B2. Okay. So table B2 ni kamu kena betul-betul faham how to use it. First of all, tengok dia punya fasa. Kamu nak guna fasa liquid ke fasa gas? Please remember, nilai CP ni adalah berbeza untuk fasa yang berlainan. Okay, so kan kamu ingat kita nak kira enthalpy kan sama dengan CP dt kan? So CP ni kita dapat daripada table B2. Okay, dan table B2 pun kamu kena tengok. Dia ada 2 different form depending on the information. Most of the time form pertama, but sometimes can be form kedua. So beza dia kalau form pertama, A plus BT plus CT square plus DT power of 3. Kalau dia adalah form 2, A plus BT plus CT power of minus negative 2. Rarely form 2 lah, most of the time you use form 1. Second, unit dia, please be very careful. Sometimes the CP value, the unit is in Celsius, sometimes can be Kelvin. So kalau kamu kalau pengiraan tu melibatkan Celsius, make sure you use Celsius. If the calculation stipulates you have to use Kelvin, you have to use Kelvin. Okay, tu pun kamu jangan lupa, kamu kena betul-betul tengok table. Okay, and then next time saya beritahu kamu, pengiraan dia CPDT, right? So from T1 to T2. T1 adalah suhu permulaan kamu, T2 adalah suhu yang kamu nak capai. Contohnya macam tadi kes yang phenol ni, katakan from 25 to 45, right? 42.5, right? So T1 is 25, T2 42.5. T1 adalah suhu permulaan, T2 adalah suhu pengairan yang kamu nak capai. Dan masuk dalam format dia. Kalau form 1, A plus BT plus C2 square plus DT cube. Itu adalah pengamiran. Okay, then bila kita selesaikan pengamiran dia ada formula. Kamu ikut saja formula saya beri dalam notes ni. Equals to A. You choose the value of A. Make sure A ni you multiply 10 power of minus 3. Okay, again I repeat, the value of A ni you have to multiply 10 power of minus 3. In bracket, T2 minus T1. So katakan dalam Celsius, kamu buatlah 42.5 minus 25. Done. Plus B per 2. Formula dia kata dia akan menjadi B per 2. The B kamu tengok dalam table. And don't forget multiply with 10 power minus 5. Again, divided by 2. In bracket, T2 power of 2 minus T1 power of 2. Means katakan T1 is 25. So 25 power of 2 T2 is 42.5. 42.5 power of 2 minus 25 power of 2. So on and so forth. Then plus C per 3. So the C is multiply with 10 power minus 8 divided by 3. T2 power 3 minus T1 power 3 plus D per 4. Your D is times 10 power minus 12 divided by 4, T2 power of 4 minus T1 power of 4. Sepatutnya benda ni kamu dah familiar, kamu dah belajar dalam CPP, temu pun kamu dah belajar. So by right you should know, but I just explain again if let's say in case you forget. So nilai entalpi ni pun kamu dah boleh tengok. Katakan kamu you increase temperature, nilai delta H ni akan jadi positif. Tapi kalau kamu cool down or you reduce temperature, delta H ni mesti negatif. So kamu kena tengok, kalau katakan kamu tengok ini adalah pemanasan tapi nilai Q kamu negatif, kamu pun salah. Pemanasan Q positif, cooling down Q negatif. Okay, so even I want to check calculation, saya tengok ni je. Kalau saya tengok kamu buat pemanasan tapi nilai Q kamu negatif, saya tahu confirm salah. Ataupun nilai Q kamu ni, kamu nak kira H ni untuk cooling down, but your Q is positive, then I know it's definitely wrong. So there's a way for you to check as well. Okay, next. So example macam saya tunjuk dalam contoh ni, katakan aceton, I want to cool down from, this is, katakan aceton saya nak cool down from 181.4 kepada 300, katakan so I do the calculation, make sure you check correctly, katakan macam aceton ni, CP dia boleh liquid, CP dia boleh gas. So make sure you check, for example, I want to calculate for CP aceton gas, I make sure that I take the value of the CP for the gas phase. And then when you calculate, your enthalpy unit will be in kilojoule per mole. Enthalpy that you calculate, if you use the table B2, the heat capacity table, the enthalpy value will be in kilojoule per mole. So that is to calculate untuk perubahan suhu. So for change of temperature, most of the time you will use table B2, but sometimes you can use table B8 yang saya tak tunjuk dalam contoh ni, tapi nanti kemudian ada contoh yang saya akan tunjuk how to use table B8. Okay, next, change in pressure. So remember I told you sometimes certain compressor you might need to calculate Q, sometimes you don't need to calculate Q untuk compressor. Okay, macam mana ni boleh berlaku? It depends on your phase of the compound yang kamu masuk compressor tu. Okay, katakan for the compressor or any equipment ada perubahan pressure, if it's ideal gas, you don't have to calculate enthalpy. Enthalpy dia adalah kosong. Kalau compound yang masuk compressor tu ataupun equipment yang perubahan pressure, kalau dia ideal gas, you don't need to calculate Q. Kalau dia non-ideal gas, okay, kamu kena tahulah apa tu ideal gas, apa tu non-ideal gas. Ideal gas macam N2, H2, O2 tu semua ideal gas. Kalau bukan ideal gas and the change of pressure is less than 5 atm, you don't need to calculate delta H as well. Means tak ada perubahan, tak ada enthalpy, perubahan enthalpy, tak adalah nilai Q juga. But it's more than 5 atm, you have to calculate the enthalpy if there are change of pressure more than 5 atm. So contohnya katakan path yang tadi saya tunjuk ni, path ni kan. So kamu tengok path yang terakhir kan perubahan tekanan, right? But it's only from 1 atm to 3 atm. So perubahan tekanan less than 5 atm. So that enthalpy delta H6 ni adalah kosong sebab perubahan tekanan dia less than 5 atm, delta H6 tu kosong. Okay, so then if it's liquid, okay, solid or liquid, you have to calculate using V delta P. V itu apa? V itu adalah specific volume. Delta P itu adalah the pressure change. The pressure difference, sorry. So specific volume ni nak tengok pada mana? Kita tengok daripada Google up this liquid, apakah specific volume dia. You multiply with the difference of the pressure. Contohnya daripada katakan daripada 5 atm to 12 atm. Perubahan tekanan dia 7 atm, right? So 7 atm multiply with the specific volume. Sebab tu saya kata for compressor, certain compressor you need to calculate, certain compressor you don't need to calculate. And last one is kejap. Okay, contohnya dalam case ni lah daripada 1 atm to 3 atm, since the pressure change is less than 5 atm, the delta H6 is 0. And last one is the change of phase. Okay, so bila ada perubahan fasa, means kata kamu punya path tu ada perubahan fasa, kita kena include the heat. Tapi macam mana kita nak include heat dia? Kamu kena tengok pula perubahan fasa tu daripada apa ke apa. Contohnya, from gas to liquid, from solid to liquid is melting, kan? Okay, so the heat of from solid to liquid, we will add the heat of melting. Contoh tadi case tadi tu, kan first saya panaskan daripada 25 to 42.5, right? Dan bila sampai 42.5 dia bertukar fasa. So enthalpy untuk perubahan fasa tu adalah sama dengan heat of melting. If I change from solid to liquid, and then this must occur at the melting temperature. So mana kita nak tengok heat of melting, tengok table B1. So contohnya katakan acetic acid ni kamu nak melt from solid to liquid, meaning you bring to 16.6 Celsius and then you change the phase. The phase change punya path tu enthalpy dia adalah 12.09. Okay, then katakan terbalik pula. Katakan kamu nak buat daripada liquid to solid, means kamu nak sejukkan dia mencapai melting temperature tu supaya liquid bertukar solid. So when it's opposite, we call it as what? Solidification. Okay, solidification ni pun ada enthalpy dia. Tetapi enthalpy dia adalah negative heat of melting. So kamu faham kalau dia solid ke liquid, heat of melting, liquid kepada solid, enthalpy dia adalah negative heat of melting. Means heat of solidification tu adalah negative heat of melting. Okay, now if I go forward lagi, liquid to solid, vaporization, right? Liquid pergi solid, vaporization. So liquid to solid berlaku vaporization will occur at the boiling temperature. Ini katakan acetic acid, saya nak tukar dia menjadi vapor, saya kena panaskan kepada 118.2, it will become vapor. So once it reach 118.2, dia bertukar fasa from liquid to vapor. The heat is we call as heat of vaporization. And kamu hanya tengok table B1 again. Contohnya dalam kes ni, the heat of vaporization for acetic acid is 24.39. Okay, terbalik juga. Katakan kamu nak condensation daripada vapor, kamu nak tukar liquid. So, kamu bayangkan dia dah vapor yang suhu tinggi, kamu bawa turun sampai boiling point, which is 118.2, dia akan bertukar menjadi liquid balik. Katakan liquid acetic acid kan. So, bila dia terbalik, kita panggil condensation kan. So heat of condensation tu adalah negative heat of vaporization. So dia just terbalik je. Kalau kamu terbalik proses tu, nilai enthalpy tu kamu letak negatif. So solid to liquid, heat of melting. Liquid to solid, negative heat of melting. So again, liquid to vapor, heat of vaporization. Vapor to liquid, negative heat of vaporization. Okay. So I cannot go further. Okay, so the heat and everything, you just look from the table B1. Okay, so I cannot go further. I already finished the time. So I will try to finish by tomorrow. I think it's a bit hard. Energy balance ni banyak. So kalau saya tak sempat habis by tomorrow, probably I will do a video to finish up the energy balance part. Sebab week 10 dan seterusnya saya dah tak boleh buat lecture because you already have your lab session. Okay, so that's all for today. I will see you tomorrow as usual. Okay, thank you. Bye-bye.